at the topic scales. Every map has a scale. Sometimes there are more than one scales on a map. However, in reality, there are basically three different types of scales. And therefore, before we go into these three types of scales, we want to first of all understand what we mean by the term scales. Now, students, a scale is actually the relationship between the distance on the map and the real distance on the ground. For example, on a 1 to 100,000 scale map, 1 centimeter on the map equals to 1 kilometer on the ground. That is basically what the scale is actually saying. However, we now go into what are the three different types of scales. Now there are three types of scales. These are a statement scale, which is sometimes referred to as a word scale or a verbal scale. Then you also have the representative fraction or the rational scale, sometimes called the ratio scale. Finally, we have what is called the linear scale. Now let us look at them individually. The first one is the statement scale, and it states how many centimeters is equal to the number of kilometers on the surface. For example, 1 centimeters to 10 kilometers means that 1 centimeter on the map is equal to 10 kilometers on the surface. Similarly, 5 centimeter to 1 kilometers means that 5 centimeter on the map is equal to 1 kilometer on the surface. For good measure, 3 centimeters to 5 kilometer means that 3 centimeters on the map is equal to 5 kilometers on the surface. Now a statement scale is useful to us because it allows us to calculate the distances that is on the map. The ratio scale tells the map reader that 1 unit on the map is equal to a certain number of units in real world distance. Example, 1 to 2500. That is a ratio. That is a ratio scale. Now this means that 1 centimeter is equal to 2500 centimeters in real world distances. In other words then, 1 centimeter on the map is equal to 2500 centimeters on the ground. Finally, the linear scale. This basically shows the distances between two or more prominent landmarks on the map. Here we have an example of the linear scale that you may probably see every now and again on your maps. Sometimes you have only one linear scale, another time you have two. In this case we have two. One is in miles and one is in kilometers. So those are the three scales that we will eventually encounter on our maps from time to time. Now, if you think that they are all far and separate from each other, think again. They all are connected. That is the reason why we're able to convert one scale into another, and vice versa. So let us see how we're going to do this. So the next thing we're going to do is scale conversion. This is where we're going to convert one scale into another, and it's very simple. Let us first of all convert statement into a representative fraction or a rational scale. So here we have a statement of 1 centimeters to 2 kilometers, which basically means the same as 1 centimeter is equal to 2 kilometers. So how we're going to convert this into what we call a ratio or rational or representative fraction scale? Simple. we have 1 centimeter to 2 kilometers. We first of all place the 1 centimeter over 2 kilometers multiplied by 100,000 centimeters. Wow! Where did that 100,000 centimeters come from? Out of the blue? Not really. You see, we use the 100,000 centimeters because 100,000 centimeters is equal to 1 kilometer. So whenever you're given a certain amount of kilometers within the ratio, or should I say within the statement, we simply gonna convert the kilometers into centimeters by always multiplying that amount of kilometer by 100,000. In this case, we have 2 kilometers. So we're going to convert 2 kilometers into centimeters simply by multiplying 100,000 centimeters by the 2 kilometers. Hence, we will get 1 over 200,000 or 1 to 200,000 because it can be expressed either as a fraction or a ratio. That is why we have the term ratio scale or representative fraction. Let's try it another way. Oh, before we move on, we must always use 1 as the numerator in the fraction, or we always use the 1 as the antecedent in the ratio. No other number. All right? So, let us try another one. Here we have another statement, 2 centimeters to 5 kilometers. We are now going to convert this into a ratio or representative fraction. How do we do this? Well, first of all, we're going to multiply our 5 kilometers by our 100,000 centimeters. Remember, students, 100,000 centimeters is equal to 1 kilometer. So in order to get our scale properly represented, right, we'll have to multiply our 5 kilometers by 100,000 centimeters. Therefore, we will get 500,000 centimeters. And just like that, we have converted our kilometers into centimeters. Then we're going to divide by 2, which is the 2 centimeters in the statement. So let us look at how we go about it. So we say 5 kilometers multiplied by 100,000 centimeters all over 2 centimeters. This will give us 500,000 centimeters divided by 2 centimeters, which will be equal to 250,000 as our answer. So given that figure, we're just going to simply put 1 over 250,000, or we're going to use 1 to 250,000 as a ratio. Remember, we must always use 1 as the numerator in the fraction or the antecedent in the ratio. That is why we always have 1 over a particular number or 1 to a particular number. In this case, when we divided the 500,000 centimeters by the 2 centimeters, we got 250,000 centimeters. We got 250,000. All right. Hence, we simply say 1 over 250,000 or 1 to 250,000. Let's do it another way. There is another way. So we're going to look at that. Instead of doing it that way, we can also do it this way. 2 centimeters all over 5 kilometers multiplied by 100,000 centimeters. Again, we multiply our 5 kilometers by our 100,000 centimeters because we simply want to convert our kilometers into centimeters. Hence, we always multiply our number by 100,000 centimeters. And 2 is all over that one, right? This will give us 2 centimeters over 500,000 centimeters. Now, we're simply going to cancel out the 2. So 2 into itself will give us 1. And then we divide 500,000 by 2, which should give us 250,000. Hence, 1 over 250,000 or 1 to 250,000. So that is how we arrive at our ratio or representative fraction scale. Remember, students, this is just another way. Alright, so we could do it the first way that I showed you, or you can do it this way. But always keep in mind that in working out the representative fraction or the ratio, we must always use 1 as the numerator, or in the ratio, we must always use 1 as the antecedent. Alright? Remember, 1 is always the numerator in the fraction, and 1 is always the antecedent in the ratio. No other number. Alright? That is why we always use 1 over a number or 1 to a number. Hence, in this case, we got 250,000. So we say 1 over 250,000 or 1 to 250,000. And that is how we convert our statement into a ratio or representative fraction scale. Let us now convert our linear scale to a statement. Wow! You can actually convert that illustration, that diagram into a statement? Yes, we can. Very, very simple. First of all, let us examine how we're going to do this. The first thing we're going to do is to place our ruler along the linear scale, ensuring that the 0 on the ruler is also under the 0 on the linear scale. Then we will measure how many centimeters are there between the 0 and the next number on the linear scale. For example, the distance between the 0 and 1 kilometer on the ruler is 2 centimeters. Therefore, the statement should read 2 centimeters to 1 kilometer. That is all well and good, right? But let us see what we're talking about here. So now here we have our linear scale, all right? And our linear scale, as you can see, has both kilometers and miles, but we're working with kilometers. So first thing we're going to do is to place our ruler along our linear scale, just like that, ensuring that the 0 on the ruler is also under the 0 on the linear scale. Now the idea is to find out what is the distance between the 0 and the next number on the linear scale in order to arrive at our statement. So when we measure between the 0 and the 1, we realize that the distance between the 0 and the 1 is 3 centimeters. So here we have our 1 kilometer. So the distance between the 0 and the 1, right, when we use our ruler to measure, is approximately 3 centimeters. Therefore, our statement scale should read 3 centimeters to 1 kilometer. Again, students, our statement is therefore 3 centimeters to 1 kilometer. Let's try another one. Here we have another linear scale. Now the idea is to find out what is the distance between the 0 and the next number on the linear scale. In this case, it is 10 kilometers. So we're going to now place our ruler right there at the base of our linear scale. And when we measure it between the 0 and the 10 kilometers, we have 1 centimeters. So between 0 and 10 kilometers is 1 centimeters. That is the distance between the 0 and the 10 kilometers on this particular linear scale. Hence, our statement should read 1 centimeters to 10 kilometers. Again, 1 centimeter to 10 kilometer. That is our statement. And just like that, we just converted our linear scale into a statement scale. Alright, so now we are going to do another one. So we're going to have our scale put up, and then we're going to place our ruler at the base of our scale. Again, as you can see, the zeros are lined up. So the 0 on the ruler is lined up with the 0 on the linear scale. Alright? So the next thing we're going to do is to try to determine what is the distance between 0 kilometers and the 10 kilometer on the linear scale using our ruler. So the first thing we're going to do is to do that measurement. And when we do that, we realize that it is 2 centimeters and 3 millimeters. But we can't say 2 centimeters and 3 millimeters. We have to convert all of that into centimeters. So instead of saying 2 centimeters and 3 millimeters, we say 2.3 centimeters. And that is the distance between the 0 kilometer and the 10 kilometer mark on the linear scale. Alright? So the distance between the 0 and the 10 kilometer mark on the linear scale using our ruler is approximately 2.3 centimeters. Therefore, our statement for this linear scale should read 2.3 centimeters to 10 kilometers. Yes, students, sometimes when we're doing this, we end up with a decimal figure. Alright? So that is the statement for this linear scale. Again, when we use our ruler to measure the distance between the 0 and the 10 kilometer mark, we see that it is approximately 2.3 centimeters. Hence, our statement for this linear scale is 2.3 centimeters to 10 kilometers. Again, 2.3 centimeters to 10 kilometers. We have our scale here. Again, the idea is to find out what is the distance between the 0 and 3 kilometers. So we're going to place our ruler, again ensuring that the 0 on the ruler is also directly under the 0 of the linear scale. Now, when we do our measurement, we realize that the distance between the 0 and the 3 kilometers on the linear scale is approximately 3 centimeters. Which means our statement should read 3 centimeters to 3 kilometers. And that's how we convert our linear scale into a statement scale. Finally, let us now convert our statement scale into a linear scale. So we're doing the reverse. A while ago we just converted the linear scale into a statement scale. Now we're going to do the reverse and convert our statement scale into a linear scale. So the first thing we're going to do is to make sure that we first of all interpret the statement. So here we're given a statement of 2 centimeters to 5 kilometers, which basically means that every 5 kilometers on the linear scale measures approximately 2 centimeters. So having understand this, we will then draw the linear scale accordingly. So how do we do that? We're now going to use our pencil and ruler to draw a line. So here we have our ruler, and then we're going to draw a line right here. Now, let me make it clear to you students. You can actually make your linear scale as long as you want. You don't have to make it as long as short as mine is. You can make it even longer than that, or even a little shorter than that as well. The key thing is you actually represent what is there on the statement. So again, the statement is 2 centimeters to 5 kilometers. So now we put our line there along our ruler, and now we start at the 0 and mark off every 2 centimeters, because remember, it's 2 centimeters, all right, to represent 5 kilometers. So we first of all start at the 0 here, then we mark off every 2 centimeters. So we say 2, 4, 6, 8, 10. We're stopping at 10. If you want to go to 12 or if you want to go to 14, it's up to you. As I say, you can make it as long as you wish. Now, having done this, we are now going to count off or number our scale. All right, so we're going to say 0, and we're going up by 5 kilometers each time. So we say 0, 5, 10, 15, 20, 25. So now we can remove our ruler. And there it is. Voila! Our linear scale is complete. And this linear scale represents 2 centimeters to 5 kilometers. Let's do another one. Remember, as I said a while ago, you can make your scale as long as you wish. Alright? So it can even be longer than what I have right there. Let's do another one. Here we're faced with the task of converting 1.5 centimeters to 2 kilometers. And we're going to turn that, as you know, into a linear scale. So we're going to use our ruler and pencil to construct a line. So here we have our ruler. Here we have our line. Now on this line, we're going to mark off, starting at the 0, 2 centimeters along the ruler. All right, for every 1.5 centimeters. So again, we're going to start at the 0, and every 1.5 centimeters, we're going to make our marking along the line. So we have here 1.5, 3, 3.5, 6, 7.5, 9, 9.5, 12. All right. So we managed to accomplish all of that by marking off 1.5 centimeters each time going up along our line, right? Now the next thing we're going to do is to simply go up by 2 kilometers each time. So we start at 0. So we're going to number our scale now and start at 0. So we say 0, 2, 4, 6, 8, 10, 12, 14, 16. So we go up by 2 kilometers each time because remember, 1 centimeter is equal to 2 kilometers. So we have to count up by 2 centimeters each time after we mark off our 1.5 centimeters each time, right? And then that is it. There is our linear scale that basically reflects the statement 1.5 centimeters to 2 kilometers. All right, let's do one more. So we're going to convert 2 centimeters to 1 kilometer into a linear scale. All right, so here we go. Again, we have our ruler. We're going to draw our line along our ruler. I decided to stop at 12 centimeters. So we have to now go up each time on our ruler by 2 centimeters. Again, we mark off by starting at 0, 2, 4, 6, 8, 10, 12. Then we're going to now number our scale by saying 0. And we're going up by 1 kilometer each time. So we say 0, 1, 2, 3, 4, 5, 6 kilometers. And there it is, class. Our linear scale is complete. And this linear scale represents the statement 2 centimeters to 1 kilometer. So let us do a quick review, shall we? First of all, we must construct our linear scale using our ruler and pencil to draw a line. Then we mark off the points along the ruler on the line, and then number the points marked off to complete the linear scale. And this completes our lesson on scales. I hope you enjoyed it and you have learned something new and it was easy for you to understand. Do have yourselves a great day and take care.